Hey everybody, Swarsky here. Let's go ahead and get into interpreting ratios and proportions. Another way to say we're going to work on some word problems. So we're going to apply these properties to find some missing values based off that. Okay, you should be on page 21. So if you need to get there, pause the video before you keep going, just so you're ready to roll. And off we go. Now, oops. There we go. So here's how we're going to start. Obviously, I got a little bit of a pun going. Mr. T is 6 feet tall, casts a 7-foot shadow. If he's standing next to a tree, casts a 28-foot shadow. How tall is the tree? Well, we're obviously going to need to set up some distances and some lengths and kind of get an idea of what we're looking at. So first thing always when we have these, even if we have a picture, is mark your figure up. So we know Mr. T is, we're going to do this one together, is 6 feet tall, casting a shadow. So when we do that, we're saying, well, which way does the shadow go? Well, it makes sense that it's kind of all coalescing or kind of coming this way. So let's say his thing is 7 feet, 7 feet. The tree's casting its 28-foot shadow. That means this whole thing is 28. And what I'm looking for is this piece. That's kind of my X value. Well, if you look, we have some corresponding pieces, right? We got this height, and then we got this length, right? Total. And when we think of these as triangles, we have this triangle and this one. So those are similar triangles, okay? So when I say, well, how would we find that? Well, let's figure out we can do it two ways. We can either set up our proportion, our two ratios, or we can figure out the scale factor. I'm going to show you both. So the first one is, well, here's our related pieces, right? We know if we're going to go from this one up here, right? Set, that's going to be 4 times as big. So that's my scale factor. So if I want to do the same thing here, 6 feet up to here, I would just simply do 6 times 4. So I know that the tree is 24 feet. We'll put units in there just to make sure. The other way we can do this is that we know also that if I have my ratios, I know that there's a ratio from 7 to 28, and that's also equal to 6 to whatever that one's going to be. Cross multiply. Now, some things should be kind of thought of. If I'm going down like this one here, the X value should be smaller than 28. Hopefully that makes sense to you. But then I can just cross multiply. 7x equals 6 times 28 is 168. Divide by 7, divide by 7. And guess what? We get the exact same thing. X will be 24 when we divide that. Okay? So you can kind of decide how you want to think about this. Sometimes it's easier to think about it as a proportional statement, or other times it's easier to get the scale factor and then work your way from there. Okay? But we should end up either way with 24 feet. So we're looking for kind of what's missing. And the easier thing to do is figure out kind of what pieces we're talking about, what's missing, how we're making our connections. So please, please, please mark your figure like I did here. Okay? Let's see kind of how we deal with the other one here, or the next one. So I simply just have a scale here. So here's how I'm going to kind of give you this piece. So it says the model car has a scale of 1 inch to 2 feet, which means for every inch on the model car is 2 feet for the real thing. So I'm going to give you the question. So what if maybe I say the whole length of the car, so from there to there in the model, is 7.5 inches. My question is, how long is the actual car? Knowing the scale, knowing what the model is, see if you can figure out what that is going to be. I'm going to give you a second. Pause the video, see if you can figure out what the actual length of the vehicle is, knowing that the model car is 7.5 inches long. Okay? Well, that would mean that the model, or the scale from here to here, right? If we go from 1 inch, if I go up, That means if I use the same thing, 1, 2, right? I'm saying that it's going to be 7.5 times bigger. So I can just simply multiply this by 7.5, and I'll get the overall being, or x, we'll call it, is equal to 15 feet. Another way to think about it is if I know that for every inch is 2 feet, that'd be the same thing because I know I want to get 7.5. Well, what would the actual thing be? Cross multiply. Again, 1 times x is x. 7.5 times 2 is 15. And you see, I get the same thing. Okay? Oops, there we go. Another question I'm going to ask is, now it's going to be a little different, is how many, so I want to ask, how many times, knowing this, how many times bigger is the actual car to the model car? Not the scale factor, but how many times bigger? Once you think about that, see if you can come up with a value. You can pause the video, think about it, and then we're going to talk about that because that's different. Saying scale factor and how many times bigger it is a little different. See if you can figure that out. All right. Now I can say scale factor based off my ratio here is 2 to 1. For every 2 feet, I have 1 inch. But that doesn't change how many times bigger. When I think of times bigger, in this case, I need my units to be the same. Then I can start thinking in that mindset, which means this would have to change, right? So I can say, well, 2 feet, that's the same as saying for every 1 inch, that's equal inch. That's the same as 24 inches. Well, that would tell me that this is, now that we have the same units, now I can start speaking to how many times bigger. And if you look at it in this case, we're saying that the actual car is 24 times bigger. Okay, so that the scale factor can kind of be whatever the ratio is. And that can be the different units, whatever it is. That's the same thing with miles per hour, miles per hour. That ratio, that scale is different than how many times bigger when we're talking about kind of scaled models or scale factors based off of things like maps or buildings or drawings. The only difference is I would need to have the same units. Then I can start thinking in this case, right? Kind of an interesting way to think about stuff. All right, let's try this. Pause the video when you get a chance. So let's do a person's 5 feet 6 inches tall, casts a 7-foot shadow. That would be, that's what I was going to do. I was going to change this, and I forgot to. Let's call it 6 feet because it's on, or 6, we'll say centimeters. Boop, so not that. So that's this piece here. Cast a 7-foot shadow, or 7. Gosh, I have my units all mixed up. Apologize about that. Let's say centimeters. This is meters. Meters. Okay. See if you can figure out how tall said flagpole is, knowing we have this. 3, 2, 1. Give it a shot. All right. So we have some ratios here. We have 7. What I look at a couple different ways, and I'm going to show you a different way that we can actually do it. So 7 to 37, that can be equal to 6 to whatever, right? Which means cross multiply. I can get 7x equal to 222. Divide by 7. Round to the nearest tenth if you need to, which we do on here. There's how tall our thing is. Now I could also do, if you watch, I'm going to cross multiply by the same thing. I could also have a ratio between this. This to this has the same ratio as these two, as x to 37. Why does that work? Well, when I cross multiply, you see I'm cross multiplying by the same thing, and I still get to this point. Okay. Now I could again do the scale factor, right? 37 divided by 7, and then simply just whatever I get as a result, simply just multiply 6 by that scale factor, and I'd be the same place. Okay. Alrighty. Let's see. Another thing, we know that if we were going to go from Chippewa to Duluth is 147 miles. Actually, how far apart would the cities be on a map if it has this scale? See if you can figure out that. Go ahead, pause the video and see. And we're off. Now this is different if you're looking on the solutions in the Daily Doc. This will be a little bit different. And I apologize about that. But hopefully you see that we have, you can simplify this to a scale factor, right? 1 to 6. Okay? So for every 6 miles, I get an inch. So I could simply just take 147 divided by 6 and get my end result. 1 second. I need to calculate. This is the one I didn't do. So you have a 1 to 6 ratio. Apologize for hearing sounds here. This is me grabbing a calculator when I should be prepared. So I could just simply go 147 divided by 6. So I'd get 24.5, oops, sorry about that, inches. Right? Because I'm looking to see how far they would be on a map based off this scale would be 24.5 inches. I could also set this up as a proportion, right? Proportion statement is where we have two ratios, 5 to 30. I want to know what this is, knowing that I have 147 miles. Okay, same thing, cross multiply. I would do that. I'd end up getting the same thing. Okay? Good. Last one. Now we got a couple steps on this one, so I want to see if you can handle it. You don't have, obviously, the wording on this one. So the two ladders are leaned against a wall, such as to make the same angle with the ground. That's what creates similar triangles, right? We got that. This is 90 degrees, so we got angle similarity. So we know these are similar triangles. The 10-foot ladder reaches 8 feet up. How much further up the wall does the 18-foot ladder reach? So there's a couple things you got to kind of break down. Which one's which? Where do the places go? What do I need to find? And remember, I want to know how much further up the wall, not how high up the wall that one goes. See if you can figure that out. Pause the video. You got a couple steps. Let's see how you do. All right. So the very first thing we got to make sure we're doing is marking our figures. So we got 18 feet here. We've got a 10-footer here. We've got 8 feet from here to here. So I actually have to find two things. I need this, and then eventually what I need, well, I'm going to change my color. Eventually that doesn't work. Eventually what I need is this piece. This is my ultimate goal. So we'll call this part Y. Why not? So I'm going to go, we know for the 10-foot ladder, I'm going 8 feet up. Well, if I have an 18-foot ladder, the question is how far am I going? I'm going to cross multiply here. We see we get 10y equals 14.4. That's feet, so that's this total distance up. Well, cool. Well, now I have the total. If I want to find this piece, I simply just take the 14.4 minus the other one to see how much further up I'm going. Hey, and I get a total of 6.4 feet. Or if you wanted to turn that into inches, you could just simply just take 12 divided by, or 0.4, so 4, so 2, that's 2/5. So you could just simply take 2/5, or you can leave it right here, 2/5 of 12. But that's just fine, 6.4 feet, or you could write it out, feet, same thing. Okay, nice job. Last little piece I want to talk about is like, well, everything we've had here has a diagram. What if there is no diagram? What if there is no picture? Well, obviously, the first thing we'd want to do is, this isn't in your notes, by the way, so just keep in mind this is just a little, hey, what am I going to do? Obviously, the first thing is you'd want to sketch, do something small where you can kind of get an idea of what's going on. You don't have to be an artist. You just sketch, label your figure when you do that, and then from there, figure out what you're solving for, just like we did on this one. Where's your value? Where's your variables? Where's your values? Here and here, like we did on that. And then finally, like we did also, what solve, set up, figure out how you're setting up, figure out how you're solving, and then solve. Okay? Pretty self-explanatory. If you don't have a diagram, make a diagram. Okay? Last but not least, what do we need to do for our class practice? We have these pieces here, Skills Core Extended. Do what you need to. At the very end here, there's an exit slip on your daily doc. That needs to get done for sure. That is going to be graded. 4 questions, not on this stuff, but just on previous things. We'll do one more thing on the last piece. So other than that, I hope you have a great day, and we will see you later. Let me know if you have questions.